Hi, welcome to another lesson with Dr. Hill. Today what we're going to be doing is we're going to be building an electrical circuit, an electronic circuit, that will allow us to test the conductivity of different materials around the home. So that's our experiment, is to find a whole bunch of different things and say how conductive they are, whether they conduct electricity or don't conduct electricity. Remember, current is the flow of electricity. Current will flow through materials that are conductors, and it will not flow through materials that are insulators. So we can build a very simple electronic circuit with an LED on it to tell us whether electricity is flowing through a material or not flowing through a material. And this is how we're going to do it. So we'll have a look at the board here and have a quick look. Now, up here at the top is the circuit we've already built, the very simple circuit that we built to light up a single LED. When you connect up this circuit, you get light out of your LED. Remember, we always should use a resistor between our voltage source and our LED just to make sure we don't blow the LED. Because too much current will blow the LED. Remember, the resistor adjusts the current of the circuit, not the voltage. Okay, so we still have 3 volts going through this circuit, but we have a lower current because of the resistor. Now we'll talk about resistors in a future lesson. Now, what we're going to build is this circuit. So instead of having the wire coming directly from the LED back to the negative terminal of the battery, remember your LED has to be connected up correctly. The long leg goes to the positive end and the short leg goes to the negative end. Now in this case, our short leg of the LED is going to be connected to a wire, a jumper wire, with a little metal tip on the end of it. So these basic jumper wires, this thing here. So we can use this and we can handle safely using the black plastic cover because it's an insulator. The plastic cover to the wire is an insulator. The metal here is a conductor. Okay, so let's have a look at the circuit. I've got my battery pack here, which is giving me the 3 volts, and we've connected up our leads to the battery pack. Now what I'm going to do is I'm going to take the negative lead of the battery pack and keep it available for testing. Okay, so that is, if we look at the back end of the circuit, I've got the negative connected directly to my testing point here, my testing lead. So that's the negative end of the battery and the testing lead. All right. The positive end of the battery, and we need to come out after the LED because we need to connect the LED to the battery. If I just connect that up, you'll see that we have electricity flowing and the LED lights up. So what I can do is I can take different materials. For example, in the circuit board, remember we had the question whether this rail here was connected to this rail here. See the blue rail here, the blue rail here. Now there's a gap between those blue rails, so that suggests that it's not connected, but it's always worth checking. So for example, I can stick that in there and stick that in there and discover that it's not connected. Some of them are a little bit stiff. There you go. So these 2 rails, this blue rail here and this blue rail here, are not connected, whereas this hole down here is connected, and we can see that with our light. So let's take our 2 I'll push that out of the way for the moment, and let's take our 2 leads. We can just test them. You can see the light. All right, so that switches on nicely. And let's look at a few things. Here's a $2 coin from Australia. All right, it's not worth much, worth about £1. And it's made out of metal though, so I expect this to conduct electricity. And if I put my 2 tips on there, I light up my circuit. So the LED lights. The little flickering is usually due to me not being able to hold it steadily against the thing. Here's a paper clip made out of metal, so we would expect it to conduct electricity. Let's test it. And there's the paper clip is conducting electricity and the LED lights up. Okay, here is a clothes peg. Now I'm just going to touch the wood on the clothes peg. Does the wood conduct electricity from one side to the other? Well, let's have a try. And we touch it and we see no activity from the light. If I was to touch the metal part of this clothes peg though, I will see conductivity. So what I'd like you to do is go around your house and find lots of different materials and test them and see. So cardboard, paper, the paper, we'll try the paper in just a second. Cardboard, paper, do these things conduct electricity? There are items you might find on the beach, and you might want to know whether they are conductors or insulators. Most conductors are metals, so it's a good way to test whether something is a metal or not, or has a certain amount of metal in it. Sometimes the foil wrapping in food can conduct electricity. So for example, if I was to take a piece of aluminium foil, which is here, a bit of aluminium foil, we can test that, and this is a metal, so it should conduct electricity. All right, and so we'll just have a quick look. Okay, and it does. Now, we are using a very low voltage in this circuit and quite a low current, so we don't have to worry too much about safety here, but always remember when you're handling any electrical current is to make sure you don't touch any of the metal parts of it, because it's a good habit to get into even with low voltages and low currents, because a significant current of 1 amp can easily kill you, and if it's driven by high enough voltage. So it's really important to get into the habit always of not having a functioning circuit with any of the metal parts of that circuit in contact with you, all right, with your skin, because you can get a shock, and potentially a lethal shock. So let's just have a look at another thing. This is a piece of carbon rod that I found on the beach. You find these on the beach all the time because they're used in electrical motors, and they fall off and they fall out of any electrical motor that's been dropped in the sea and rusted away. This thing doesn't rust, which actually makes it a very useful property. It wears out faster than the metal that it's in, but it doesn't rust like it. So it's got a number of different properties in devices. So what are these things used for? Well, they're used to conduct electricity. Now this is carbon. It is not a metal. And yet let's have a look at what it does. So here's my carbon rod on the bench, and if I connect up the two ends of that, I'll see that that lights up the LED quite nicely. So the current flows through that beautifully, and it's not metal. All right. So you can attempt to do that same experiment with pencil lead, which is also carbon. It's graphite. Sometimes you might get the connection to work, but a lot of pencil leads, even though they are said to be graphite, have quite a lot of clay mixed in with them to make them soft or hard pencils. So quite often they don't conduct electricity. We say there's graphite, and graphite is what makes the mark on the paper, and the clay is what gets brushed away when you brush your paper in the end. But it should conduct electricity, but quite often it doesn't. All right, so have a go with the conductivity tester. Test a whole bunch of different things around your home. Write down what you find. Write down the results. So what was the material? Did it conduct electricity? Yes or no? I'll put a table in our worksheet for school, and if anybody else wants to do this at home, feel free. And I'll see you in the next lesson. Bye for now.